Thank you for taking the time to watch my presentation today. My name is Brian Hageman with Deluge Technologies, and this was produced for the chairman and commissioners at the Arizona Corporation Commission and the stakeholders at the Utilities Division Resource Planning Group. Today I'm going to be talking about sustainable solutions to make Arizona energy self-sufficient using my invention, the hydraulic engine that has zero emissions and can run on solar thermal, geothermal, waste heat, or any other heat source. My hydraulic engine is an engine that runs on hot water. It uses expansion of liquefied gases in reservoirs similar to a thermometer. The basic principles of the hydraulic engine concept are that liquids expand when heated, and liquid CO2, liquid carbon dioxide, doubles in volume over the temperature range of 80 to 180 Fahrenheit. The liquid is expanded and moves pistons with a hydraulic force. My hydraulic engine operates silently and produces zero emissions. It requires 90% less energy to produce equivalent power. It employs industry standards, proven components, and is manufactured from non-toxic recyclable materials. It's energized by solar thermal, geothermal, or waste heat. The hydrothermal power conversion is 4 times greater torque than normal engines. It's applicable for hydraulic and electric power, desalination, and liquid pumping, and the hydraulic engine is made here right in Arizona. I've proven that the technology works, and I have validation at World Laboratories. The Department of Interior lab, the Humid Desalting lab right here in Arizona, tested our original desalination equipment. The Department of Energy at Sandia National Lab in New Mexico validated horsepower on a dynamometer at their testing lab in Albuquerque. The Department of Energy Rocky Mountain Oilfield Testing Center in Wyoming proved my engine can run on geothermal power, and tests there prove that I can pump crude oil out of the ground using geothermal power. The Indian Institute of Technology in Madras, India, did over 250 solar water pumping tests there in Chennai, India. And the Federal Laboratories Consortium gave me an award for outstanding technology development based on the work I did in Wyoming. And this type of award is not easy to get. First off, you have to have a technology that's been proven in the field, and my technology has been proven many times. The technology has gotten a lot of university validation also. Here at Arizona State University, we've been doing testing there and research work for many years, and 2 master's theses have been written, the most recent here in June of 2020. The University of Arizona Maricopa Agricultural Center is where I got my start building water pumps, solar-powered water pumps using solar thermal hot water to pump water for the first time down in Maricopa. Texas Tech University did a study on liquefied gases and how they'd work in my engine, and helped me convert from liquids to the liquefied gas in our engines. And at the Indian Institute of Technology, we did, like I said, 250 tests on a solar water pump there, that and a report that was written that clearly shows that my technology is valid. My hydraulic engine comes in many sizes. It's scalable to any size you want, but we have standard sizes. The 335 horsepower hydraulic engine is a standard size, fits in a 40-foot shipping container, and that can drive many different applications, like the 250 kW electric generator, when connected to the 335 horsepower hydraulic engine, will produce 250 kilowatts of power. And that same exact engine, the 335 horsepower hydraulic engine, can be hooked up to a high pressure pump that will produce 1 million gallons per day of desalination. Smaller sizes of the hydraulic engine, a 42 horsepower hydraulic engine, same difference in applications. It'll produce a 30 kW electric generator. It can run that using solar thermal power or any other source of hot water. And that same 42 horsepower engine could be hooked up to a pump again and produce 125,000 gallons per day of desalination. Even smaller, the 14 horsepower hydraulic engine that's being designed for residential use will run off solar thermal and produce 10 kW of electric generation. That same 14 horsepower hydraulic engine could be hooked up to a high pressure pump and produce 40,000 gallons per day of desalination. Using my technology in power generation, the 250 kW electric generator uses solar thermal collectors. They're dish collectors, similar to a satellite dish for your TV, but this collects solar thermal energy, heat from the sun, and is stored in thermal storage containers that will provide 24-hour operation to my 250 kW engine. The 250 kW engine is the green block there in our 40-foot module, sitting next to a cooling tower that will be required to operate our system 24 hours a day. I'm talking with Central Arizona project engineers about a project at the Hieroglyphic Mountain Recharge Project that's located in Northwest Phoenix, Northwest County, just above the city of Surprise. The 250 kW generator would provide electricity for the recharge pumps that pump water out of the canal and into the charging basins that they use for recharging underground aquifers. This would allow CAP to become energy self-sufficient and run their pumps using my technology. Using my technology in water and power projects here in Arizona, we're looking at projects that'll be phased in, with a phase one project being a 125,000 gallons per day desalting capability plus 30 kW generator. It's two of our solar collectors. You can see a side view of that dish collector there, and it'd have two collectors and two engines. The 42 horsepower engines, one would power the high pressure pump for 125,000 gallons per day of desalting, and also the 30 kW generator would supply electricity for all our needs internally and also export electricity to the grid. This all fits on about 1/4 of an acre. You can see the phase one project in the bottom right corner, and the phase two project would add on 2 more solar thermal collectors and add solar thermal storage to operate the phase one project 24 hours a day. The phase three project on 4 acres is the 1 million gallon a day desalting facility plus a 250 kW generator. This would, like I said, would all fit on 4 acres, and price-wise, we can do a 1 million gallon a day desalting facility at a price about half of what you've been seeing paid for 1 million gallon a day water treatment centers. My focus on desalination projects in Arizona is based on a report written by the Arizona Department of Water Resources on the Buckeye waterlogged area. The city of Buckeye is sitting on a flowing aquifer that is tons of water, huge amounts of water, but it's too salty to use for human consumption or crops that fruits and vegetables for human consumption. Also, it's just the salt levels are too high and it's not being used, so we need to install desalination to make this a great source of water. the Buckeye waterlogged farms in the area. There's a lot of farming in Buckeye, and I plan to install 6 million gallon a day desalination plants that will provide pure drinking water to the farms so they can produce crops that are suitable for human consumption. Right now, they have a lot of farms there, mostly producing cattle feed and horse feed, hay and barley for the horses there. But they can produce much higher cash crops with the installation of desalination systems along the Buckeye waterlogged area. Once we have all the farmers with all the clean water that they need, we'll build a large desalination station at the end of Buckeye and keep the water that now runs off underground. We'll keep that water here in Maricopa County and pump it through a pipeline up to the Central Arizona Project Haciampa Pump Station, and that will feed water into the canal, supplementing the Colorado River water in the Central Arizona Project, and wheeling the water down the canal to customers anywhere in Phoenix or all the way down to Tucson. I've been looking at water pipeline projects in Arizona for a long time, based on this report in 2004, written for the Arizona Department of Commerce. It was written by the Battelle Institute and included a couple deluge signature projects, one of them being the Arizona-Mexico pipeline and desalting station. I proposed that we take water out of the Gulf of California in Mexico, run a pipeline to run the salt water from the Gulf of California up to Yuma, where we'd have our desalting station inside the U.S., inside Arizona, and desalinate the water using solar thermal power, and then using solar thermal power, pump the water up to the Central Arizona Project in a 100-inch diameter pipeline. This would supply a huge amount of water, and we in Arizona would never have to worry about water any time in the future. The Gulf of California is an endless supply, connects right into the Pacific Ocean, and we can have as much water as we ever need using a project like this to help supplement the Colorado River water that's being used in the Central Arizona Project now, which is going through a low period in water availability. But I believe that's cyclical. I believe in the next 50 to 100 years, that level of the Colorado River will go back up. We also plan in all of our desalination projects to use that reject salt. There's an issue with what do you do with all the salt after you desalinate water? There's a reject stream of heavy salt brine that has to be dealt with. And I'm planning on drying out that water and making rock salt and using that rock salt in our thermal storage. It'll be a part of the thermal storage that we use for 24-hour operation. And then any other salt left over actually could either be sold or put into the landfills. I've talked to engineers at the City of Phoenix, landfill engineers, that told me as long as there's no traces of arsenic in the salt, this salt could be just put in the landfills. And that would solve a huge problem for the desalination industry. They just need to dry out that heavy salt brine. The City of Phoenix is also looking at pipeline projects. The drought pipeline is for the drought contingency issues, and they want to pump water from the Salt River north to supplement water that they feel might be slowed down by the levels in the Colorado River. My suggestion to them is that, yeah, build these pipelines, but you need to use our deluge solar water pumping for any pipelines and not place any further strain on the electric grid by using big electric motor pumps. In conclusion, any Arizona water projects must use Arizona solar thermal power. Hydraulic engines with solar pumps will make Arizona water sustainable. The Deluge Technologies hydraulic engines are made right here in Arizona, and projects could be funded with Arizona banks. So let's make Arizona energy self-sufficient. I love Arizona, and I'm doing everything I can to make Arizona energy self-sufficient. Thank you very much for your time, and have a great day.